All right. Hey guys, today we're going to be going over our Unit 1 test review. So in case you didn't know, for all of our tests, we do make a test review note video. This is a great opportunity for you to watch the video and catch up on any parts that you might have missed, or if you had any questions on your test review, you can watch through the video and see if we cover that question. Today we're going to just go through a handful of the questions on the review. First one we're going to look at is number 2 here. We have 4/3 x plus 5 is equal to -3. All right, so the first thing I want to get rid of is that positive 5. Remember, we're trying to isolate our variable x, so we want to get rid of this plus 5. We do that by subtracting 5 to either side. So we are left with 4/3 x is equal to -8. All right, so now in this step, you could have learned a handful of different ways on how to solve this. I know at least in my classes, we talked about 2 or 3 different ways of solving it after this step. So your teacher might have taught you a different way. I think the easiest way is just as if this was like 4 times x. The way we undo that operation is by dividing, right? So if this is 4/3 times x, to undo that, we will divide both sides by 4/3. Even though it looks ugly with the fractions, remember fractions are friends, especially now that we have our fancy calculators. So if you have your calculator, we'll have -8 divided by, you might do alpha y equals. So -8 divided by 4/3. And we get -6. So x is equal to -6. Now remember, the best part about our Unit 1 test is that you have the opportunity to plug in these answers to check yourself. So I'll do that right now. Maybe I have 4/3 and I'm replacing the x with -6, what we just solved it for, plus 5. And now whenever I hit enter, it should be equal to -3, in which case it is. This tells me that I solved my problem correctly. Great strategy for your test as well. Now we're going to slide down and talk about number 3. One more of the fraction problems. Remember, again, fractions are friends. You don't need to be afraid of them, especially now that you have your nice calculators. So we're here. I need to get rid of that -2. We're going to do that by adding 2 to both sides. That goes away. I'm left with y divided by 3 is equal to 6. Just a friendly reminder, if some of my students feel more comfortable writing it like this, 1/3 times y is equal to 6, and that is also okay. You're welcome to write your question like that too. Put that over here in parentheses. However, right here, if this is y divided by 3, what's the opposite operation of dividing by 3? Multiplication. Yes, multiplying by 3. So whatever I do to one side, I do to the other. 3, this will reduce. Multiplying by 3 and dividing by 3 cancels out to 1 or reduces to 1. I'm left with 1. Y is equal, 6 times 3 is 18. Again, we want to get in a healthy habit of making sure that we're taking our answers and plugging them back in. So I have, let's see if I put this in parentheses, I'm replacing y with 18 divided by 3. Minus 2, and I want to make sure it equals 4, in which case it does. Again, this tells me I did my problem, I solved it correctly. So we're going to slide down here and check out what's happening here on number 6. So we have 3 times x plus 1 minus 5 equals 3x minus 2. All right, so I'm going to hippity-hoppity distributive property. 3 times 1x is 3x. 3 times positive 1 is plus 3. And then my minus 5 drops down. All right, now on the left side, there's still some more simplifying we can do. Remember, you always want to combine like terms if you have any. So here's some x's there, and then right here I have some regular numbers, so I can combine those. Remember, if they're sitting on the same side of the equal sign, you use the same sign. So this is a positive 3 and a minus 5, or you can think of it as 3 minus 5. 3 minus 5 is -2. 3x minus 2. So hopefully right here in this step, you're making an observation and you're like, hey, the left side is the same as the right side. So hopefully you have some little red flags going off and you're being told in your mind that's an all real numbers case, all right? Well, let's say you didn't quite recognize that. You maybe decide to move your x's over here and your numbers over here. So we'll subtract 3x, subtract 3x. All right, and then right here I'm going to add these two to the other side so those go away. Now I'm left with 0x is equal to 0. Okay, well 0x is the same as just 0, right? Because no matter what I plug in there for x, let's say x is 10. 0 times 10 is still 0. So we usually just write it as 0. And then when you ask yourself, does 0 equal 0? Is this a true statement? And the answer is yes, that is a true statement. So in this case, when all of your variables and all of your numbers cancel out, you should know that that is all real numbers. All real numbers. And sometimes we write it like this too. All right, but again, hopefully you recognized it in this step right there. And you recognize that the left and the right side were directly equal to each other. And so hopefully you saw that that was going to be all real numbers. All right, let's go ahead and take a look next door at number 9. So kind of the same thing. I'm going to scroll down, leave some space over here. So this one is a perimeter problem. So the perimeter of the rectangle is 20 inches. All right, so remember perimeter is the distance around a figure or all sides added up. So all the way around this is 20 inches and it wants us to find the value of x. All right, so perimeter, we're going to add up all of our sides. So first, let's see, I'm going to fill the rest of this in, 2x minus 1 and 3. So a couple different ways of solving this one, but ultimately what we want you to do is combine like terms, okay? We're saying that this side plus this side plus this side plus this side. So we're just adding up everything. So if I go around and I add up all of my x's, I have 4x. And then if I go through and I add up all of my integers, I have positive 3 and positive 3 makes for 6. 6 minus 1 is 5. 5 minus 1 is 4. So I'm at positive 4. And then what can we set that equal to? Well, hopefully you remembered in the question it said the perimeter is equal to 20 inches. So we'll set it equal to 20 inches. Now we have an equation that we can solve for x. We'll do that by subtracting 4 to this side. And now we're left with 4x equals 16. And then this is 4 times x. The opposite of multiplying by 4 would be to divide by 4. 4 divided by 4 is 1x. And then 16 divided by 4 is 4. Now, even in this step, this one did ask us to find the value of x. You always want to be careful in the perimeter and area problems and make sure that you're answering what the question is asking. Did it ask for the value of x, or is it asking you for your length and width, in which case it wants you to go back and plug those values in. If I take the 4 and I plug it back in here for x, I get 4 times 4 plus 4, which is a lot of 4s. And does that equal 20? Let's see, so 4 times 4 is 16. 16 plus 4 is 20. So that tells me I solved my equation correctly. And we're going to look at one more over here. We're going to check out number 10. And let's look at number 10. All right, so we have 2x minus y equals 12. And the problem is asking us to solve for y, all right, solve for y. So this comes from your literal equations practice. So we're trying to isolate our variable y. So here's y right here. I first want to knock out this 2x. How can I move the whole 2x to the other side? It's a positive 2x, so I'm going to do the opposite and subtract 2x. So I'm left with negative y equals, now remember, I can't directly subtract 2x from 12, so I'm just going to line them up side by side. Now you could have also wrote negative 2x and a positive 12. That would be okay too. All right, so once I'm here, I'm really close, but it wanted us to solve for one positive y. Right now I have a negative y. So remember, you can think of that as like a negative 1. And to get rid of that negative 1, we're going to divide everything by negative 1. All right, now ultimately all that's going to do is reverse the sign on everything. So we have positive y, this will become negative 12, and this will become positive 2x. Now again, you could have also had this, positive 2x minus 12. These two things are equal to each other. We still have a positive 2x and a minus 12. Positive 2x and a minus 12, or a negative 12. Over here on your vocab, really make sure that you are familiar with all of these terms, especially our all real numbers and no solution, some special cases there. Let's check out the ones we have left on the back. All right, so number 12, it says write and solve an equation that models the following situation. So it wants us to write our own equation. So on number 12, it's asking for how many windows washed will the cost of the two companies be the same. So let's look at our two companies. So we have company 1, Clean Fast. It's $15 plus $2 per window. So hopefully you're thinking that per, what is that per talking about? That is indicating multiplication. So for our first company, our equation will be $15 plus $2 per window. We'll say W for window. And we want to know when these two companies will cost the same, so we're going to set them equal to each other. All right, so we can see when will they be the same, at how many windows do they need to wash to have the same cost. So then our second company here is $5 plus 3 per window, so that's $5 plus $3 per window. So now that we've set these two companies equal to each other, we can solve for W to see how many windows they need to wash in order to have the same cost. So let's say I decide to move my variables to this side and my numbers to this side. I like to do mine in one step like this, so I will bring my W's over here, and after I'm done with that, I'm going to move my numbers over here. Now sometimes you guys like to do those in two separate steps, and that's totally okay too. On the left, 15 minus 5 is 10, and over here 3W minus 2W is just 1W. Alright, so we're done there. This is telling us once each company washes 10 windows, the price is going to be the same. Now remember, you can always take your variable and plug it back in for W to make sure that these two things are in fact equal. Alright, and then the last one we're going to talk about here, I guess we could call number 14, 15, I don't know. Wichita. I think that's how you spell it, but probably not. Anyways, so Wichita Falls, Wichita has a population of 45,000 people, and it's losing 1,000 people a year, or per year. So they're losing 1,000 people per year. And then Watauga, Texas has a population of 32,000 and is gaining 600 people per year. When will the two towns have the same amount of people? So it's kind of a similar question to what we saw in the last one. So we're going to do a similar thing where we're going to write an equation for each city and then set them equal to each other to figure out when will they be equal to each other. So for Wichita, we had 45,000 people, and they were losing 1,000 people per year. All right, so we did minus 1,000 per year. And then for Watauga, we have 32,000, and they are gaining 600 people per year. Hopefully that's not cut off. All right, so we set up our equations, we set them equal to each other, and now we just need to solve. So I'm going to decide to move my variables to this side and my numbers to this side. So I'll first move my variables by adding 1,000y and adding 1,000y. And then the same step, I'm going to subtract my numbers to this side. Again, if you like to do those in separate steps, that is totally fine also. So 45,000 minus 32,000 is 13,000. And that's equal to over here, 1,000 plus 600 is 1,600 y's. And then I'm going to divide both sides by 1,600. Divide by 1,600. 1,600 divided by 1,600 is 1 y. And over here I'm going to get my calculator out. And I'm going to do 13,000 divided by 1,600, or 1,600. And we get 8.125. Alright, so that means after 8.125 years, they will have the same city population. Alright, if you have any other questions over any parts of your test review, you can either check the test review answer key that should be posted on your teacher's Canvas page, or go see one of the Algebra 1 teachers up close and in person in tutorials. Go team, good luck on your first test.